Hello everyone. Today let's solve the problem 860. So previously we had done with the try topic, right? So let's solve some problems on the greedy approach, man. Right? So today let's solve the problem on this one, the problem number 860, lemonade change. Right? So let's see what does the lemonade change state here, the problem state here. Right? So we sell the lemonade for $5 each. See here, we sell the lemonade or each lemonade for $5. Right. So customers pay with 5, 10 or the $20 bills. See here in the this one input, we have 5, 10 and 20. Customer pay with $5 or $10 or $20 bills. We must always give the correct change, right? So just remember this one, we must always give the correct change. Starting with no money, we need to return true if we can serve all the customers, otherwise we have to return false. Right, starting with no money, we need to return true if we can serve all the customers, otherwise we need to return false. Right, so that's what the question states here. See here in the explanation they have given wonderfully. From the first three customers we collect three $5 this one, five bills in order. This is fine. Next, from the fourth customer, we collect a $10 bill and give back 5. We have collected 5 and we have given back 5. Right, so we have collected 10 and we have given back 5. This is fine. From the fifth customer, this one, we give $10 bill and a $5 bill. So this we will give, and one more. We are left with two $5 bills. So we'll give one $5 bill. Since all the customers got correct change, we will be outputting true here on this case. Right, so this is fine. Right, so it is possible, so we have to return true in this case. Now let's come to the example part here. We have 5, 5, 10, 10 and 20. From the first two customers we collect 5 and 5. From the next customer, this one, next two customers in the order, we collect a $10 bill and give back a $5 bill. We have $5 bills here, so what we'll do, we'll give back both. For the next two customers we'll give 5, 5 each. Right, so next we'll go with the last customer, nothing but 20. We collect 20. For the last customer we cannot give the change of 15 back, because see here we have $10 two bills, right? $10 two bills, right? So here if we give 10, we have to give this one 5 more, or if we give 20, we cannot give 20, we have to collect $5 from the last customer. Right, so this is not possible here in this case. Right, so for the last customer we cannot give the change of $15 back, because we only have two $10 bills. Since not every customer received the correct change, the answer is false here. In this case we have to return our output false. So we have been given constraints, you can just look into it, and I hope the question part is completely clear along with the example part. Right, so let's do one thing, let's quickly discuss the approach. The same thing, let's quickly discuss the approach part. The same thing they have clearly mentioned in the example itself. Right, let's quickly discuss the approach, and then followed by the complexities, and then let's write the code. Right, so first thing I want to tell you here is we will be going with a greedy approach. Right, so we'll be going with a greedy approach. So we will be starting with the empty cache in hand. So we will be starting with empty cache. So I'll just write here empty cache. Right, so first customer, this first example we will be considering. So the first customer pays 5 here, $5. Right, so the first customer pays $5 here. This is fine, so no change. Right, so we will keep 5. Right, so we will keep $5 as it is. Right, so we have count is 1. So second and the third customer both pay $5 again. So this is first customer, second and the third customer again pays $5 itself. Right, so $5 itself. So the count is still 1 now for this one. So now we will keep $5 each, for $5 for each basically. Right, so this one $5 we will be keeping this one, and the count becomes from 1 to 3, because second and third customer also paid the $5 note itself. Right, so let's move on with the fourth customer. Fourth customer pays $10. Fourth customer, what he does, he pays $10. Right, so then we will be giving back 1 5, because one lemonade cost $5. Right, so we have to return the customer $5. Right, so what we will do here, we will return the customer $5. Right, so we will give back one $5. We are left with two fives and one. Right, so we are left with now, uh, instead of 3 we are left with two fives, right? So two fives and one tens, one tens, right? So I'll just give you a tens in the sense one $10 note. So this is fine. One two fives and one tens, right? So this is fine. Now let's come to the fifth this one customer, right? So fifth customer, what he does, he pays 20. See here, the final customer, he pays 20. So this one we will collect 20 from the customer. So we will be going with the best greedy choice, right? So we can give $10, one $10, one tens, and this one fives here, right? So what we will do, we will give this one entirely one tens. Now we don't have any tens, and one we are left with this one. Let me erase this one and let me make this one fives. So we'll be giving one $5 note. If we considering note, if we are considering the note, so we will be giving one $5 note and one $10 note. So this is fine, man. So this will be one $10 note and one $5 note, right? So we are left with only one $5 note. So now this will be we can write in this way. So we will be going with one $10 comma one $5. So this is fine. Yeah, we are left with one five and zero tens now. We are left with only one fives now, right? So we are left with only one five, this $1 note. So zero tens. So all are served here. In this case, all are served, and in this case, we have to return true because we were able to, right? So give the customer, and we are left with one fives as well. So in this case, we need to return true. So the output that we got here is true. Basically we were able to serve, so we will be returning true here in this case, right? So the output that we got here is true, boolean value true, which is equivalent to the output that they have mentioned for the example one within the question, right? So the output that we got here is true, which is equivalent to the output that they have mentioned for the example one. So our approach works absolutely correct here in this case, right? So we are done with the approach part. One more thing, what is the greedy rule here for $10? So let me tell you this one. For the $10, always give back one $5, right? So this is the rule basically, right? So for $10, always give the one $5, and for the $20, right? So for the $20 here, so always prefer 110 and 15. For the 20, always prefer 110, this one sorry, $110 and one $5, right? So always prefer $110 and one $5, right? For this one, so let me erase this one, for $20 basically, right? So this is the rule basically, if possible. Otherwise, if we don't have 10 at all, then if we have three $5, we can just go with that as well for the 20s, right? So always prefer 110 and 15. If it is not at all possible, then if we have three five this thing $5, then we can go with that, right? So this is fine. This is the rule. So we are done with the approach part. So I hope the approach part is completely clear. As we are completely clear with the approach, let's do one thing. Let's quickly discuss the, what do we call, uh, complexities part. So what will be the time complexity and the space complexity, man? Here the time complexity and the space complexity would be big of n and big of 1. So the time complexity would be big of n. Why it is big of n here? We will be scanning the bills array once, right? So we will be scanning the bills array once. So I'll just go with, uh, we'll be scanning the bills array once. So overall time complexity would lead to big of n, right? So what will be the space complexity here? The space complexity would be big of 1. Why it is big of 1 here? So we will be making use of only two counters. One is 5 and another one is 10, right? So we'll not be making use of 20 directly, right? So either we'll be going with 5 or 10, right? So only two counters 5 and 10 are used here. So overall space complexity would lead to big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of 1, big of n and big of 1 respectively. Now as we are done with the approach and the complexities part, we are left with the coding part. Let's start writing the code, man. First, as usual, we have to keep track of the numbers of fives and $10, $10 bills that we have. So here in this case, I'll just go with int 5 equals 0. Also, 10 equals 0. This is fine. Next, what shall we do? Let's process each customer in order. So I'll just make use of the for loop here. This one will be int b of bills. So within the for loop, what shall I do? If the customer pays $5, no changes needed. So I'll just go with 5. So this is fine. So else, I'll just go with else if so b equivalent to ton. Then what I'll do? If the customer pays $10, then we must give $5 as change, right? So let me write the simple if condition for that. If 5 is greater than 0, we should be having the $5 notes first of all, right? So for that, if it is greater than 0, then we have to decrement. We have to give it to the customer, right? So let's give one $5, and also we have to keep the $10 months. Let me increment 10 here. This is fine. Next, else if we cannot give the change, then in that case we have to return false basically. So I'll just return false here. This is fine. Now this else if the customer pays $20, right? So this is for when customer pays 10 this one $10 bill, right? So if the customer pays $20, then we will be going with the best greedy choice, as I've said, one $10 and one $5, right? Also, if it is not possible or if we are not having $10, then we can go with a three $5. Sorry, for the if the customer pays $20, then we can go with a one $10 bill and one $5 bill, or we can just go with three $5 bills if we don't have the $10 bill. If it is not possible at all, we need to return false in that case, right? First, let's go with the best greedy choice here, one $10 and one $5. So I'll just go with if here 10 greater than 0 and 5 also greater than 0, then let me decrement 10 and let me decrement 5 as well. This is fine, man. Let me come out of this one entirely. Otherwise, we have to try giving 3 into $5, right? So this one, I'll just go with else if 5 greater than or equal to 3, then uh, 5 equals 5 minus 3. This is also fine. If either of them or if neither works, then we fail, right? In that case, we have to return false. So I'll just go with else return false. Simple, right? So we are almost done, man. So I'll just do one thing. So if all the customers are served successfully, then we have to return true in this case. So did I miss something here? Mm, 5 equals 5 minus 3 I have given. This is fine. Otherwise we are trying $5. This is also fine. Mm, this is also fine, man. Let me give here. Let's do one thing. Let me return to if all the customers, if we are able to serve all the customers, then we have to return true in that case, right? So let me hit the return button. So this is it for the code basically. We had discussed the same thing step by step actually. Let's see why this is taking. So what happened to this one, man? Copy this one and stays. Let me refresh this one. Oh, this is also taking a lot of time. Just give me a second. Let me disconnect the Wi-Fi and connect this one again. So now we are having the error at line number 7. Else without if. So we have not written if at all here. Let it directly go with the else. So I have written for loop here. This is fine. So yeah, I have not written if condition at all. So first, if we have $5 bills, then let me open this one here. This is fine. else we are going with, right? So this one, let me add this one at the end. Let me format this one once so that this looks good. Let me hit the run button. I hope this works now. Mm, Missing return statement. I have given return true, right? So sorry, I have given return true here. This one, let me place this one here, not here. So let me cut this one. Yeah, we have to place, this is Java, right? So we have to place it here. Let me hit the run button. I hope this works now. Let's see. Yeah, now you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So I can clearly see here all the test cases are getting passed. Means the code works absolutely correct on this case, right? So yep, this is it. Basically, whatever the code that we have written, I hope whatever the code that we have written is completely clear, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.